Welcome to Programming Rainbow. In this video, we'll continue on the series of Conway's Game of Life, written in C and SDL2. This is the 6th video. So if you're just starting out with this video, you can go to github.com, Programming Rainbow, and this one will be called Conway's Game of Life, C, SDL2. You can git clone this repository, move inside the directory, and let's look at the code. So I'm just going to show you real quick what the final project looks like. So this is Conway's Game of Life. You can look up all about this if you don't know anything about it. Look it up. It's got basically 4 simple rules that decide whether a cell is alive or dead, and you can actually create really complex kind of structures or organisms, or you can even build like programming things like it in here. So it can get pretty complicated, and it's just fun to play with. But this is it running. We can tell it to run faster through the generations, or we can slow it down. We can pause it. We can clear it. We can use our mouse to just edit it. You know, we can draw things. And let me just do a random one. Okay, I'll just speed it up a bit. Okay. So if this is a stable shape right here, but if I just add one to it here, it will start blowing up. And we could make a glider. Let's see if we can make a glider. Right over here. Then I think it's like this. Whoops, not that one, but this one over here. I think that's right. And it should glide this direction, I believe. There we go. It glides. It's going to come over on the other side of the screen, and then it runs into something. Anyway, so you can check it all out, but this is Conway's Game of Life. And in this video, we are going to be setting up let me just show it one more time. Right here, this display here that says the speed that we're running at, or if we're paused or not. That's what we'll be doing on this. And we'll be using true type fonts. So yeah. Now, if you did just clone the repository for this video, what's in the source directory that we're going to be working in, that is actually the code from the final video, but this is the 6th video. So we're continuing on with the code that we left off with in the 5th video. So you're going to want to delete this directory, copy video 5, rename it to src, and then you'll be where we are. So let me just show you that without this source directory 6 in here. And I'll do a clean run. And here it is. See, there's no display up here. So that's what we do have the speed and all the other stuff, but we don't have the ability to display anything yet. So that's what we're going to be working on. We're going to be working with true type fonts. So this is going to be another module that we load in SDL2. So let's look at these functions real quick. To bring on true type font, to bring it online, it's ttf init. And it doesn't take any parameters, and it returns 0 on success or -1 if something fails. This is kind of what we've already seen before. It's just there's no flags going into it. And the way we shut it down is ttf quit. So this will be very easy to implement. And we will need the header file, this SDL.ttf, we will need that as well. So right away in main H, let's add that so it doesn't complain. So this will be SDL2 if it's in the standard place it should be, and then SDL.ttf.h. And that's going to give us access to that. So now we can go into init SDL.c, and I'm just going to copy this one right here. It's close enough. I'm going to yank it. I'm going to put it after the image. I'm kind of loading these modules in order, and this one takes no parameters. And this one is called TTF. Okay, and we can say error initializing TTF. Okay, and I'm going to switch this to TTF get error. And that's it. That's all that we need for that one. So now that we have this, that we're bringing it online, the way that we take it down is we go to game free. And since it was the last in, it's going to be the first out. So we got TTF, so I'm putting it on above the other ones. and this is quit. So the reason why we're bringing this online is we need a couple different things. So we need to be able to open a font. This is kind of like creating a texture or surface, but we're creating a font. So we use TTF open font, and it's going to return a pointer to a TTF font. And the arguments for this is the actual path where the font is, and then a point size. So it says point size, not pixel size. So those are different. You could look up the differences, but this is just an int for the point size. And I'm just going to put this in the main.h header for the size of the text that I want to use. But this is going to give us a font that we can use then. And we can close the font. I'm just showing you real quick. This is closing font, just kind of like a free surface or destroy texture. We just pass in it and it's freeing that. So we've kind of seen this before. But the reason why we want this font is because we want to be able to create a surface that has something written on it, and we need the font to do this. So this is TTF render text blended. The blended means we're going to have the nice anti-aliasing and everything else. The text will look nice. So this is going to return a surface. It doesn't return a texture that's hardware accelerated. It only returns a surface. So we will convert this into a texture, but it returns a surface. And this first needs the font that we created. Then it needs a string. And then we need an SDL color. Okay. So I'm just showing these real quick as an overview. This is kind of where we're going. We're going to be able to put something onto a surface now, and then we'll turn that surface into a texture. So you get the idea. So the first thing we need is this font. So I'm just going to put it underneath. I'm going to have a font size and a font color, but since we're doing the size first, let's put that in here. We'll say font size. And we're going to use 32, although you can change this to be whatever you want it to be. I could do this two different ways. I can hold the font inside a game, but then I'm going to make a message. We're going to make message C and message H, which is going to hold a struct and functions on it the way that we've seen before, sort of object-oriented style, but simpler. But I could hold the font in game, but then I would need to pass it in every time. So I'm going to hold it inside of the message struct. So we are going to kind of need to create this message struct first. So I'm going to create two files. So I'm going to call it message H and message C. And this is going to look very much like everything we've been doing so far. And the first thing we need to do is pull in, include main. Okay, and then we are going to create this struct that is called message, and it's going to have a render. So we're going to pass in a copy of the the pointer to the render, and I am going to hold on to a surface, a texture, and a font. So it'll kind of make sense as we build it up here. These are going to be all the things I need to basically generate a texture that I want in the end. Okay, so we need a render to do anything with textures. And we're going to take this font. So I'll just do it first. TTF font. I'll just call it font. Simple. And this is a pointer, sorry. And we're going to use this font to create a surface. So we need an SDL surface. And I could keep this surface locally in the function and just get rid of it. But just for simplicity, I'm just going to put it here. You could do it either way, though. I'm just going to call it surface because it's the only surface in this program, so I'm not going to give it a special name. If there was other ones, though, I would call it like, text surf or something like that, and this would be text font. But since this is internal to this, and there's going to be no other surfaces in here, I'm just going to call it surface. And then the image, I'm going to call it image because that's kind of what I've been calling every image, and that's in its own struct. I've been calling it image. So this is a texture. And this is a pointer. Image is a pointer to texture. I feel like I spelled this wrong. Let me just put this here real quick. This is a pointer. I'm trying to think of everything that I could have done wrong there, and it's a pointer. So we have the render. We need a font. We're going to use the font to create a surface, and then when we have the surface, we're going to use that surface to create a texture. We are going to need a color, but it's not going to change, so I don't need that. And we are going to need a rectangle. And that should be everything we need for the actual. So we are going to have the free. We're going to have it draw itself, and we're going to have an update. The update is anytime the message needs to update. That'll handle all the updating. So I'm just going to call it update. When we're creating it, something could go wrong. So this is a bool. When we free it, that's a void. When we update it, we are creating surfaces and textures and stuff like that. So something can go wrong there. So that is going to be a bool. And when we draw it, we're not worrying about anything when we're drawing it. So that's going to be a const. It's going to be a void. So 2 of these are returning whether they failed or not, and 2 are not. So this is a message new. And this, just like everything we've been doing so far, it'll be message is a pointer to a message struct. Let's just start with this for now. We're going to change this later. And this one is free. And this is the same thing. And then we have an update, and the update can fail because we're doing all this kind of heavy lifting in here. We're creating a surface, creating a texture. So I'm going to return bool on this. And this is update. And I'm just going, the M is a pointer to a message struct. And the very last one is the draw. This one's going to be const, because nothing ever needs to be changed. So if I accidentally put a bit of code in here wrong, it's going to tell me that I've messed up, because nothing in here should change the message struct. Okay, so that's what this one's going to change up here later. We're going to add some stuff, but that's just enough to get us going. Let's get into the message. So right away, we're going to include that. So this is the new. Okay, so this is going to be the same thing. We're passing in the pointer to the pointer because we're going to calloc it. And the reason why I'm using calloc and not malloc is because I never want to deal with uninitialized data. So okay, now right away I'm going to check to make sure that this is not a null pointer. I'm just going to do it explicitly here because I'm following the rest of my code. We'll use the formatted printf. Well, this is the file. I don't know if this is the file formatted printf. However it works, this is the one where we can put the file descriptor. So this is the std error. And we'll say on this one, error in calloc of new message. And let's put the, I put an exclamation, so I'll just follow that. Okay, so right away I'm going to switch this over now to a, so I can just use M. So we'll just say M is a pointer to a message struct. I'll just dereference message one time, and there we go. Since I'm passing a render in, which I forgot to put it here, but there should be an SDL render. Let's make sure that this is in the header. That this does need to be here. There will be two other things in here, but the render needs to be there right away. So since that render has been passed in now, I'm just going to do the So I'm just going to set the render so I can just use M now. So I'm just setting the render that I passed in here into its internal render. So I was passing in color, but I'm not going to do that. I'm going to deal with color later, but I don't need it to hold it in the struct. I can just put it as a pound defined constant. I need to load the font, and I'm going to load it here in this new, because I only need to load it one time, but I need to use it whenever I update. So I'm going to do that. And then I'm also going to set the rectangles X and Y just to 10 and 10, just to move it off the very left-hand corner by 10 pixels each way. And then I'm going to start working on the font here, and then we're going to do the cleanup of this right afterwards, so we can clean up the font as well. So this M font, and we've looked at this function. It's this TTF open font, and it needs the location of the font itself and size. So we did set the size already to 32. So we have that, and it's returning a font, so we know how to deal with that. So TTF open font, and now this is relative to where the binary is going to be in the top level directory here. There is a font folder here in the same directory, and inside of it is this free sans bold TTF. So that's what I'm just going to put in a relative path here, which is fonts. That's this folder right here, a directory, and then free sans bold. And for the size, I'm going to use that pound define, that font size. Font size right there. Okay, now we just need to check to see if this is valid. So I'm just going to say bang a font. This needs to be an M. And we'll say error creating font. But we're also going to get the message. So we're going to use, this is TTF. So I'm going to use TTF get error. So that is us. We're created a font now, or we've populated this. We've created a font on the heap, and we've saved the address of it to our font pointer. Okay, and we're checking just to make sure it was actually created. So let's deal with cleaning this up now and cleaning this font up. So we got this message free. I don't need this up here. right away, we need to make sure that we are dealing with a valid pointer. So I'm going to dereference message one time because this message is a pointer to a message struct. I'm going to dereference it one time. The reason why is because I need to send in a pointer to a pointer so I can actually change the pointer where I'm setting it later to null, because this is going to be held in the game struct and I'm setting it inside of this function to null. So that's why there's a pointer to a pointer. But right away, I need to dereference it because I need to make sure that the pointer to the message struct is valid. So this may be valid. Well, this will be valid because I'm passing the address. But this one will not be, or it could not be. Maybe it could be null. And if it is null, then I can't look at any of its members or anything else like that because it's null. Okay, so I'm just saying if this is a real, then I'm going to, since I need to do several things here, I'm going to do the same trick right here. You don't have to, but otherwise I have to keep dereferencing it in parentheses like this, and I don't want to. So we can do this here. So the first thing we need to do is close the font. So we've opened a font here, so we close it. We're going to close it. So I am going to make sure that now we've made sure that this is a good address. And so we have a struct to deal with, but the font in this struct may not be a good address. It may be null as well. So it will be a null when it's very first created. So depending on where we're closing down or if it crashed, I don't know if it's null or not. So I'm going to check it. So that'll be M font. So if that's valid, and then we're going to use the close, the TTF. Close font. Now, these functions can probably handle a null pointer, but I'm just being careful because it's C. You handle all the memory yourself. It's better to just be cautious. I'm also going to set it to null. Oops. Font. Okay. So I've set that member that we've allocated here. If it has been allocated, I am freeing it and I'm setting the member to null. And we also need to free the actual message struct, right? As well. So we can just free M. And then we can set both of them to null. So I can just say M equals null. And this is going out of scope. It doesn't really matter, but I'm just, yeah, this one doesn't really matter, but because I didn't do it up here, did I? Yeah, I didn't do it up here. Well, I never free it either, so that's fair. So this is going to make sure that message, which it will be a member of the game struct, will have its member set to null now. That's why we sent in that pointer to pointer. Okay. There will be other stuff in here later, but right now that is just cleaning this up. So what I'm going to do is I'm going to have this message update, which is actually going to call another helper function called message generate. So let's make the generate one first, and then we'll, because the other one's going to use this. So let's make this helper function first. I'm only using it inside of here, so I'm going to put it up here. I'm not going to put it in the header file. And this is going to return a bool, so it could fail. So we'll call it message generate. This is kind of generating the message, generating the image that we want. And we're going to have the M as a pointer to message. We also need a string. So I'm going to say const char, and I'll just call it text. So I'm just going to yank this right here. And this is a helper function, so I'm going to put it right after the free, because I'm going to use it in another function later down. Since I'm holding the pointer to the surface, I'm not going to worry about freeing the surface inside the code. And my notes are different than what I'm doing right here. I kind of changed my mind before recording. But so what I'm going to do is at the top of this function, I am going to make sure that whatever I have set in the surface and the image, whatever the surface is and whatever the texture is, I gotta free those things first, because I'm going to be using both of those. And I'm going to end up with an image, but I'm going to be using the surface to get the image. Both of those could be populated. So the very first thing I'm going to do is check to see if they're populated and free them. Since I'm doing this with both of them, I'm going to check the surface first. So if surface is something, I'm going to do, and I'm kind of doing this out of order. I'm assuming we already know what a surface is. We've used it before for set. Yeah, we have used a surface already. So this is how we free a surface. I think we've already done this before, but this is very simple. We're just put in the pointer to the surface as an argument and it frees it. Okay. And it says it can handle null. I'm just trying to be extra safe about my coding. So this is a SDL free surface, and we just need the pointer to the surface, which is M surface. I'm going to set it to null. Okay, so that is done, and I'm going to do the same thing for the image. Obviously, the very first time this is called, these are both null, but every other time it's going to be called, there is going to be it's already going to be populated with something already in the heap. So this needs to be cleaned up first, or we're kind of, we could potentially be creating a memory leak. So to free a texture, it's SDL destroy texture. We've already seen this before, so I'm not going to show it. And this is called image, is the name of my texture. And I'm going to set it to null as well. So that's right away, just making sure both of these are set to null and both of these are free and ready to be used. The very first thing that we need to do is create our surface from our font and the text that we want. Well, we have the text that we want here, and we have the font that we want was already created here, so that already exists. And assuming we've created text to go into this, it's here. Okay, so we're going to use this function right here, TTF render text blended. The blended one is like the nicer looking one. It takes a font, which we have. It takes a text, which we have, and then it takes a color. So we do need to set up color. I'm just going to use white, but then you can change it to whatever you want it to be. Okay, so I'm just going to put like white in the main.h. I think we've colored font color already. It's already in here. Yeah, we've already done this before. So these were actually separate RGB and alpha, but there is something called font color, which is actually just these exact things in a struct called font color. So I'm going to do this exact same thing, but I'm just going to put it in curly braces. And I just want white, so everything's going to be 255 because it's red, green, blue, alpha. And we've already explained this in another video. Okay, so I'm just going to leave it right like that. At the bottom here, I'm going to return true so it doesn't complain anymore. We're using this TTF render blended, and it needs a font, a text, and a color, and it's returning a surface. So this is where we're going to use the M surface. Render text blended, and M font is our font. Text up here is our text. And then we already have a color, but it won't understand if we just type in the color. because it's just a well, let's try it. It's probably going to complain, yeah. Oh, it stopped complaining, so I guess that works. The other way was I would just put it here. I would cast it to font color here, just like I did. We need to check this now. So I'm just going to grab this up here. So we're checking surface. And what kind of error message? Error creating a surface. I'm going to say error creating surface from text. So we know exactly what happened. Error creating surface from text. That's still a TTF get error right there. And yeah, that looks good. And we already have cleaning up of the... Oh, we don't. Okay. So we need to deal with cleaning up the surface. So font, surface, image, all three of these need to be cleaned up. This one is actually, we didn't create this on the heap. That was done in game. So we're just passing in a pointer. But these three do need to be taken care of. And we can set this pointer to null though. Not for game, but just for our local purposes. Okay, so I'm going to, since it's last in, first out, I'm going to go with the image first. It doesn't really matter what order, but yeah. So this one is a texture. So this is SDL destroy texture. And then we'll set it to null. And the surface as well. And it's SDL free surface. And this one is the M surface. I could have just grabbed all this code from this function right there. It's right there. I could have just grabbed it. I should have done that. Let's set the renderer to, why not? We don't need to check anything on the render because we're not actually freeing anything. We're just setting it to null. And that's pretty much everything cleaned up for the... And we could put a message down here. We could say message clean. Printf. I think I didn't capitalize it. That's just for me to kind of see what's going on. So, okay, so we have this surface that we've created. Let's, there's two things we can do. Now, in my notes, I use SDL query texture to get the width and the height of the texture for a rectangle. But since we're dealing with the surface right here, the easiest thing to do is just get the numbers directly out of the surface. We don't need to use a function that can fail or anything. So let's just do that. Because remember, we have a rectangle and we need to display our image. We need to have the width and the height, or it's not going to display correctly. So we have the m rect dot width. This is going to equal our m surface w. So surface has its own member that's w, that's width. So that's very easy. We can do the same thing for the height. Okay, so right away that's basically set our rectangle. And since we're dealing with the rectangle, we should set the X and the Y to just 10 and 10 because that's what, so it's not drawn directly in the top left-hand corner. So it's kind of 10 pixels in. So I'll say M rect, so rect X equals 10. We only need to do this once because we're never going to change these again. It's not moving. But every time we create a new image, our width and our height may be different, but our X and our Y are always going to be the same. Okay, so each time we do this thing with the surface here, we're getting our new width and height. So we didn't need to run that function anymore. Now we do have a function that is create texture from surface. So this function, create texture from surface, this takes our render and it takes a surface and it returns a texture. So this is how we can convert a surface to a texture. So I'm going to use this right here. We got a render, we got a surface, returns a texture, and then we can just check and see if the texture is null because it's going to give us a null back on failure. So that's pretty simple. So this is going to be image equals, and this is an SDL function, SDL create texture from surface, and this is M render, and then M surface. And now we can just check this right here. So I'm just going to use this one right here. And this one's going to be image. And we can say error creating texture from surface. And then we are getting an SDL error on this one because this is an SDL function. Texture from surface, that looks fine. Okay, so we don't need to query the texture anymore, so we're done here. I did have another function block down here that was checking for failure, that was querying just so we could populate the width and the height, but we grabbed them right out of the surface, which is simpler. So that is fine. So this is the helper, although this is a bigger function. The other function actually needs to create this text right here. The update function is going to create whatever this text is going to be and then call this function. That's the next one. That's update. And since this can fail, that means update needs to be able to fail too because update's calling this one. So we got struct, message, and I think there's some more to it than this. I need to know if we're paused or not and what's the delay. So we'll say we need to know if we're paused and the duration. So I'm going to change that here in update. So bool paused. Because if it's paused, we need to make a string that says paused. If it's not paused, we need to make the string for the duration. So in the duration is a double. What's going to end up happening actually is that new needs these as well. They need to be in both of them. So I'm going to add them now because otherwise we need to come back here. And I'll just yank this again. Okay, so that one is saved. So it's going to complain up here for a little bit. Let me get this signature and then I'll go up and fix it. It's these second two right here. Because what's going to happen is this new is going to call update when it's run one time. And then later on when it needs to change, it'll call it something else will call it again. But message new is going to call update. So it needs the same information. So it's going to need this information as well. because right down here, I'm just going to call it. We need to know if it failed. And we'll say message update. I think I put in paused. And this is duration. So if this fails, we're returning false from this. So I'm calling the function I haven't filled out yet, but this is the function. This function is going to call this other function. So yeah. So we need to basically, this update is basically creating the image. So it needs to be created when we have our new image instance, we do need to create an image. But every time we change the speed, or if we pause or unpause the game, we also need to recreate an image. So down here, this is going to be a little bit simpler than that big helper function above. But what I want to do is, if it is paused, I'm just going to call the message generate with paused passed into it. So if this paused comes through as it is paused, and I'm going to return this. So this is going to allow me to get the return of this function and return it from this function. So I don't have to wrap it in an if statement. I can just return the answer to it, if that makes sense. So this function, if it fails, it's going to return false. And if I just say return that, it's going to return false out of this function as well. So I'm just going to return, and I'm calling this function up here that we just created, the one that needs text, and it generates the text image. So I'm going to put text in there that is just paused. Message generate. We need M, and then we need a string. So I'm just going to put in the string paused. Okay. And if this is either going to return true or false, and this is the only thing I need to run in this function, so I'm going to return that as well. So if this is false, this is going to return false from here as well. But if it's true, it's going to return true from here, and I'm done. If this is paused coming in, we don't need to even worry about this whole double duration. We just need to make a string that's paused, so that's what's going on here. And this is going to generate now. It's going to free the surface, free the image, and it's going to use our font. This is going to say paused right here. And with our color, it's going to create the surface, get the width and the height of the surface, convert it to a text, and then returns true. And that will be true out of here, and this function will return true, and it'll be done. Now, it's a little bit more complicated if it's not paused. So then we need to create a string, but the string needs to be like the speed of the game. Okay, so this becomes a bit weird. So right now our duration is 128. So if I take 128 and divide it by our duration, that's going to give us 1. So it's like saying our speed is 1. So if I make the game go faster, I want it to be 2. So what I'm going to do is put the duration here. I'm going to leave 128 here every time. And now this becomes 64. And this will equate to 2. And if I make the duration longer, so it's 256, this will be a half. Okay? So that's how I'm kind of thinking about this. But I need to make a string. So in C, it's fun to make strings. So the first thing I need to know is how long my string's going to be, so I can create an array in the local scope here that is long enough. So I'm going to say int. Yeah, I could just call it length in text. It's fine, because I'm only doing it once. So length, and I'm going to use sn print f. If I put in null here, and I put in the length as 0, and then I put in a string, it's going to actually return me how long. This is the array, the array that I want to print to. But if I say null here, there's no array. And I say the length of this is 0. And then I give it a string, it's going to return back the length that the string would be. It's not printing it anywhere. It's just going to return back the length of it. So it's just a way for me to create a complex string and get back how long the string is. I just need the length of it. So what I want the string to be is speed. But then I use %G, and I use G for a reason. I think it was to truncate. When I do my calculation, it's going to be a double or a float. And it's going to, so say if it's 1, it's going to print 1.0000 or something like that. And if it's a half, it's going to be 0.50000. And I didn't want to print all those O's. So G kind of uses the shorter, whichever one is the shorter one. So because I'm going to use a double here, which is the duration. So what this is going to do is it's going to make a string here that just says speed, and then whatever this number is in here. So this could be 1 digit or 5 digits or 10. I don't know how many digits this is. So this is going to make the string of that length and return how long it is. Okay, I hope that makes sense. Because this could be right here. This number could be 1 or 1.0 or 1.00. And I don't know how long it is. So I want to know the length of it. So this G is the duration here, which is what I'm passing in. And it's actually not right. It should be speed. I'm sorry, I should have calculated that. Double speed equals, we already talked about this, the 128 divided by duration. And so this will be speed here. So instead of 128, we'll get like 1. If our duration's 128, we'll get 1. Okay? But this isn't the whole story. The problem with this is it gives me the length of it, but it doesn't, and C, we need the null character as well at the end of our string. So we need one more character on top of that. So I'm just going to add 1 to this right away. So this is the length that I need my buffer to be, and the length that I can write to and everything else. So now that I got this, I can create an array. I'll just call it text. Array of characters. And this will be length. Okay, so now I have a buffer of the right length. Now I'm going to use this SNPrintf again to write into that array. So this time I'm going to put the array into it. You know, this array is called text. Okay, and I know the length of this array now. It's length. So I won't be writing out of bounds or anything like that. And I know what I want to write as the text. The text is speed, G, speed. Whatever this string ends up becoming, I'm filling up this array right here with it. So this is the simple way in C to, I don't want to put some kind of, put 50 here or 10 or something like that. That is a quick way to get some kind of illegal memory. It's a good way to get a segmentation fault. So now that I have my text array or my character array, my string, I can do the same thing that I did up here. And I can just return it. Message generate, and it's M. And this time I have my text. And this doesn't need to be here. Okay. So now I'm running this function up here again, except this is going to say speed and some number on it. And we do need one more function down here, the draw one. This one's void. And this is const. And we've seen this before, so this is very simple. This is just a render copy. And we need the render. And then we need the image. And then we need how much of the source of the image we're going to use, the rectangle for the source. So that's null. We'll use it all. And then the destination to the actual render, well, we have a rectangle for that now. So, and we need to send in the address of it. Rect. That's why we need to get the rect size, because every time we create a new image, we need to make sure our width and our height is populated. Our X and Y are always going to be 10, but our width and our height will vary. Copy with a Y. And that's void, so we're not returning anything from that. So this one, this helper function can fail. We're returning false if it ever fails. This update function that calls it is returning if this helper function fails or not. It's returning the answer of it. I should put down here. Oh, actually, well, I can put down here true, but this is always going to get run one way or the other because this is a true or false. So, but anyway, I'm going to put down here return true if somehow it does get past that. Okay, so that's a whole lot of stuff and we haven't seen anything happen yet. So let's set this up. In game H, we need to add this. And then in game C, it's going to be just like this one right here. But we do need to add in these other, if it's paused or not, right? So message new. And we need this, the render. I didn't, this isn't supposed to be here, for one. And in H, I didn't add it in up here. Okay, so now it should be fine in game. This is a helper function, that's why it's here, but otherwise it should just be game up here. Okay, so now it's complaining about the arguments, that's fine. So the first thing we need is actually G message. And then we need the render. And then we need if the game is paused, so we can just do G paused. And the last thing we need is the duration. Duration is held in FPS. So I don't really want to access information directly from FPS. I don't think it's a good idea. So I'm going to kind of make a little helper. So it's not being mutated. So it's just being returned. I need the duration basically. So in FPS, I could do it. I can just access it directly. I just don't feel good about it because if I mess up, I can change the value of it. I'm just going to make a function called FPS duration, and it's going to return the duration, which is a double. And it's fine right here. So I'll just grab this. I think I put it here. So all this is going to do is just return the FPS duration, target duration. It's just like a little getter thing. It just makes me feel a little bit better. I'm always, I don't like one level to go into another level and get information out of it. I know you can just, do that, but I feel like that's easy to cause a bug. So duration. This looks a little ugly, but we're having this function here. Okay, so message. Why is it complaining about message? We need to send in the address of it. Okay, so we're sending in the message because it's creating the new, right? The render if it's paused and the duration. So this is going to create it right away. It's not paused, so it should have something. So this is creating the message. To clean it up, we'll just do the last in, first out. And we need the address of this one. Okay, so that is instancing it. That's cleaning it up. When we instance it, it's already creating a message the first time, so we should just be able to draw it. I'm going to go down here, and it draws back to front, so whatever the last thing I draw is going to be on top, so it's going to be on top of the board. All right. And we are checking if this fails, right? Okay. So later on, we might have to change around this stuff because in the right here, this is void. But when we call this, this could fail. So we will need to change this. That's not right now, though. I just want to see something on the screen. So let's just make run. Okay. And I don't see anything. So right away, I'm returning. I probably threw this up here and then forgot that I did it, so it wouldn't complain about I'm not returning true. So this comes in here and returns true immediately before it runs any of this. So that's not good. Okay, now it says speed 1. Perfect. Okay, so this is the default speed. When we speed up, we need to make it change. So basically, every time we do the speed up, we need to make it change. So we need kind of the speed up function. Right now we're doing this speed up here, right here, but we need to also tell it the other. So, and we're going to change this. So I'm going to say game bool. This could fail. Increase speed. And this is just going to be G. And what we need to do here is this one here. Okay, so we do that. And then we need to call update on the message. And this needs G message and then G paused and the getter for the FPS. Duration G FPS. Now this may fail, so I could just return on this, really? Yeah, that's what I think I'm going to do. Well, I could just wrap it. That's fine. Because it's getting very long here, this. Okay, so that is the game increase speed, and the decrease is going to look just like it. Decrease, decrease. This is the same. All this is the same. We do need to forward declare this. This is right above event. And this one is increase. Okay, so now when we go into event, we have a problem because event needs to change to bool. And if event is bool, that means a game run is going to change as well. So this will be game increase speed. And I'll just wrap this. Down at the bottom here, we need to return true. Okay, and we need to do this again for the other one. This is speed up, so the other one was going to be just decrease. Right here. So we have this problem now. We're returning a bool from game event. Game events in here, so we need to say if we need to return this if it's false, if it fails. And this is going to be a bang and return false. Now we need to change this into a bool. And that is changed in the header. And then in main, because main calls run, we have the same issue. This, we need to say if. We're not checking on failure on this one. We're going to check success because I just want to change that exit status right there. So I'm not putting a bang in it. I'm leaving it normal because I'm checking the good route. And that should be good. So let's see what happens here. Let's see if I've got it. And I didn't get it. Okay, so something bad happened. Yeah, both ways something bad happens. Okay. Okay, so this is all correct right here. So let's check game again to make sure. Return true. This is return false on something going wrong with the event. Yeah, I got that. So in the event, if this, we need the bang on this. We're checking the bad if it returned false. So that might be just the issue right there. Okay. Yeah, there we go. So it's going up to 16 speed now. And here's our normal speed. And then we can go down slower. And 0.125 is our slowest, which I think is an eighth speed. So we go up to 16 speed and go down to 8th speed. Okay. So that was interesting. In game, we have added this pointer to a message struct. We've added that in game. That is for this message kind of, what do we want to call this, a module or something, where we have a render, we need a font, a surface, and an image. This is so that we can create messages that are on textures. We have a new where we have our message. We're passing in the pointer to the render, and we're also passing in if it's paused and what's the current duration. And this is coming from FPS. Our free is the box standard free. Our update is also taking in the pointer to the message struct and paused and duration. So it can, the reason why this one here and this one is here is so that this update can actually generate the text and then internally generate a new texture for it. And then our draw is just a simple one. It's the const to the m is a pointer to a construct, so it doesn't get updated. So in in here, this is all the same that we've always been doing, where we're just calicking it. And then I'm just creating this for convenience. So I can just use M after that. So I don't have to keep dereferencing message. I'm just setting the render that I'm passing in to the local render. Here I am creating a font based on the font file over here, Free Sans Bold, and also the font size that is in main.h and it's set to 32. You can set it to different things. And I'm checking to see if this pointer is valid. If it's not, something went wrong. We're generating a message, we're returning. The rectangle that's going to be used for displaying this, the image, the texture image that we're going to create, this rectangle is going to be 10 pixels down and 10 pixels to the left of the top left-hand corner. Sorry, it's 10 to the right of the, and 10 down from the top left-hand corner. So I'm setting the X and the Y to 10, and that's going to be there the whole time. Our free is just dealing with free the image, free the surface, destroy the surface, destroy the texture, free the surface, close the font, right? We're setting the render to null, but we're not freeing it. That's done in game. And then we're freeing this actual, this message struct that we have on the heap. We're freeing it and we're setting it to null. And that's actually being set to null. That's going to be the game member. And our little message here. So up here on our update actually needs a helper function, which is actually creating the image that we want to see. So we have a text that we're being sent. We're sending text into this. We're always making sure that if our surface and our image was already set, that we're freeing it. So we don't have any kind of memory leak or we're not doing something else. So we're going to free those two. And then we use this render text blend. This is the one that is actually creating the text that we're going to see. So we need our font, we need the text that we want that we're passing in. And then we need our font color that is also in main.h. Okay, so this is going to create an image of whatever text we want. It's a surface. So we're going to check to make sure that surface is valid. And then we are getting the width and the height of this new surface we created, and we're setting that to our rect. So our rect is always going to change its width and height based on what surface was created. And then we're going to create a new texture from that surface. So this is where we need the render and the surface we created. Now we have the actual final image. Okay, so that helper function is done, and this is the actual function that runs here. So this, we're passing in paused, if it's paused or not, and we're passing in the duration. If it is paused, we're just going to run this helper function with paused as the string. If it's not paused, we need this duration. So we're going to take the 128 and divide it by the duration. This will give us 1 by default, and then if our duration shrinks, the number gets bigger, as in our speed is bigger. So this gives us a double that as our duration shrinks, our speed number gets bigger. And now we want to actually create some kind of string. So what we're going to do first is we're going to put what we want the string to be here into snprintf, but we're putting in the target character array as null and the length as null. And what it's going to do is it's going to return the length. But we do need one extra character, so I'm putting +1 at the end. So that's going to give us our target length. Now, just in this scope right here, I'm going to create a character array with that length called text. Now that we have it, we can do the same snprintf again, except we can use our character array. We can use the length, and then we're going to create our text just like we did up there, but it's going to be actually into this array now. So now that we have this character array, we can use the helper function that we talked about up here with this string. So this character array or string or whatever you want to call it in C is being used here. And I'm returning the return of this. So if this helper function succeeds, then I return success, true, out of here, and I'm done with the function either way. But if it fails, I'm returning false because this thing is going to be true or false. So this message update is going to get called here. If it fails, it's returning false out of new, and we have a problem where we're shutting down. It also gets called in game. right here, this message update, and we're checking again. If this is false, we're going to return false out of here. So this game increase, and this takes the message, it takes this, it's paused, and the duration, which is a little helper function that just returns duration from FPS, whatever the current one is. We have this increase and decrease. They do the exact same thing. It's just this was calling the FPS increase speed, and this is calling the FPS decrease speed. That used to be in the event. But since these can fail, we've changed event to a bool. And now we are checking when we call these functions. And if they fail, we return false. We return false. If they fail, if they succeed, we're fine. And we return true. And since this is turned into a Boolean, down here in game run, we need to check this, and this is also returning a Boolean. So if that failed, we're returning false for this to fail. That means we changed our main, and we put this inside, and with this one, we're not checking failure, we're checking success, because we have failure as the default. So success is the good route here. So if this succeeds, we set this to exit success. So that returns our properly from here. So I think that is everything. Like I said, there were some things in main H. We did a font size and a color, and I'm just casting it to color. I hope that was entertaining or educational, and I hope you enjoyed that, and I'll see you in the next one. Okay? Bye.